Hello everyone, welcome back to Cametarian. In this video, we are going to do the question competency focused practice question for the ICSC board 2025 and 26 exams. Okay, so we will doing the this practice question series for the ISC class 12 for the basically this is focused for the boards, okay, which is in the Fab 2026. Okay, so there is a chemistry paper one, which is a theory based paper, and then here the first type of question is multiple type question, then assertion reason question, then filling the blanks, very short long answer type question, short answer type question. Okay, so we'll start from the multiple choice question. Okay, I will give you explanation as well. So the very first question is, which of the following reaction will not form ether through Williamson synthesis? Okay, so Williamson synthesis is the formation ether formation reaction which is follow SN2 mechanism. So technically SN2 is the reactivity 1 degree, 2 degree and 3 degree. So if we look here, so this will form a product like C2H5O CH3 because it is a 1 degree, so it will give us product. Okay, now here it is C6H5. C6H5 is like the benzene ring and the chlorine. Whenever we remove the chlorine from here, we form a positive charge on the benzene ring, which is highly unstable. That's why the second one will not give us product. Now the third one is benzene ring with ONA. Whenever we remove Na, we form a phenoxide ion. Okay, this is a phenoxide ion, which is actually stabilized by resonance. So this will give us product. And the last here it is a 3 degree. Okay, this one is a 3 degree carbocation. Whenever we have this CH3C, CH3, CH3, and then this Br, bromine, and we form a 3 degree carbocation, which is like least reactive towards this reaction. So first and third give us product from the Williamson synthesis, whereas the second and fourth will not. And the question is which will not. So our correct answer is second and fourth. Okay, our correct answer is second and fourth. That means option number D. Now the second question, the correct order of acidic strength among the following organic compounds. So as we know, acidic strength is directly proportional to minus M and minus I group, whereas inversely proportional to plus M and plus I group. Now look here. This is a plus M group and minus M group. Chlorine act as both like plus M, minus I group. And for the halogen, the minus I property dominant. Okay. Now this NO2 act as a plus M group. NO2 act as a plus M group. So sorry, NO2 act as a minus M group. It is a electron withdrawing group. So NO2 act as minus M group. Okay, and the acidic strength is directly proportional to minus M. So Z will be more acidic. After Z it is Y and after Y it is X. Okay, so ZYX, this is the order ZYX. So option number C is the correct. Now the next question is for the reaction X plus RMGX. Firstly, treated with diether, and the second is it goes hydrolysis and give propane 1 ol. Okay, so we can do by two method. Like first, we can also form the product and then reverse. Otherwise, we can do also like the elimination process. So propane all is contain like propane contain three carbon. Okay, so firstly we want 3 carbon, and actually this 3 carbon is sum of R X and R. Okay, so look here, acetaldehyde contain 2 carbon and methyl contain 1 carbon, so total carbon is 3. Here formaldehyde contain 1 carbon and methyl contain 1 carbon, so total carbon is 2. Acetaldehyde and ethyl both contain 2 carbon, so total carbon is 4. And formaldehyde and ethyl contain formaldehyde contain 1, ethyl contain 2. So total is 3. So option B and C is eliminated. Now just make the product. Okay. So acetaldehyde is this CH3COH. Okay, this bond break like this way, negative and positive, and we took methyl, so it becomes CH3MgBr. Now CH3MgBr break like this way, CH3 minus and Mg plus. Now we get this product CH3COMg and this Br and this H and this CH3. Now this, after hydrolysis, this bond break like this way, negative and positive, H plus goes here, OH minus goes here. So we get our product like this way, CH3C, CH3HOH, which is actually propane 2-ol. And the product is propane 1-ol. So of course the first option is cut. Now that means the D option is correct. Okay. So we took formaldehyde like this way. It react with C2H5 and then MgBr, bond break, oxygen get negative, carbon get positive. This is carbon get negative and Mg get positive, and we get C, C2H5 and then H and then O, 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 MgBr. Okay. After hydrolysis, this Mg give us C2H5CH2OH. So this is propane 1-ol. Okay. So answer D is correct for this question. Now question number 4. An element X has an outer electronic configuration as 3d5 4s2. The minimum and the maximum oxidation state for that element. Okay. Up if it is 3d5 and 4s2, so total electron is 7. That means it is a element having atomic number 25, which is manganese. Now, the S electron become a lowest oxidation state, which is +2, and total S and D electron become highest oxidation state, which is +7. So +7 and +2 is the stable. Okay, the stable oxidation state. Okay. Then secondary amine can be prepared by the reduction. Identify the uh, compound that will form a secondary amine on the reaction with lithium aluminum hydride. So lithium aluminum hydride is a good reducing agent. It will reduce. So firstly we took methyl cyanide. This is look like this way. Now after hydrogen hydrogen, this bond break hydrogen hydrogen, and we get CH3 CH2NH2, which is actually a 1 degree amine. Okay. Then we have methyl isocyanate CH3 and double bond and a covalent bond C. Then we break a bond and then we break this coordinate bond and two hydrogen goes to the carbon. So we get CH3 and HCH3, which is a 2 degree amine. And of course it is our answer because we want 2 degree amine. Now acetamide is like this CH3CO NH2. Okay, so we break this bond, one hydrogen goes here and other one is here also. So we get CH3CH2NH2, which is also a 1 degree amine, and we want a 2 degree amine. Then we have nitroethane. Nitroethane is this C2H5 NO2 NO2. So this bond break, one hydrogen here, one hydrogen here, this bond break, one hydrogen here, and two hydrogen here. So this is also converted into 1 degree. So correct answer will be B. Okay. So isocyanide generally give us 2 degree amines. Okay. Okay, so the next question is which of the following is most basic? So for the most basic, we notice two things. First thing, a free lone pair. Other thing is basic strength is directly proportional to plus M and plus I group, inversely proportional to minus M and minus I group. Okay, so we just form aniline. This is aniline. Okay, this is aniline and this one is benzene. So it involved in the resonance. So it is not a free. Then we have C2H5NH2. Okay, then we have ammonia, which both have free lone pair, and then we have this also CH2NH2. Okay, benzylamine. So now because this is like uh, both have free lone pair, so we notice this group C2H5 is plus I group, which actually increase the basic strength. So ethylamine amine will be most basic. Okay, Ethylamine will be most basic. The free lone pair will be most basic. Then question number 7, depression in freezing point is a colligative property. At the same concentration in aqueous solution, select the solution that will show the largest freezing point depression. Okay, so the formula is depression is freezing point delta TF is equals to IKFM. If the concentration is same, so delta TF is directly proportional to I. I is a Van Hoff factor, which is basically depend on numbers of ion dissociate. Now, if we dissociate this ion, so it will be converted into 3 Na plus and 1 PO4 3 minus. So total ion will be 4. So value of I for the first one is 4. Second one is 1 because it is an organic compound which will not dissociate. Na dissociate as Na plus and Cl minus. So total number of ions will be 2. K2SO4 dissociate into 2K plus and SO4 2 minus. So total will be 3. So highest value is 4. So Na3PO4 because of most highest value of I have largest freezing point depression. Okay. Then the next question, question number 8. When the molarity of the dilute solution is multiplied by 4, what will be the resulting effect on the molar depression constant? Okay, it is a constant and constant depend on the temperature, not the concentration. So constant will unchanged. Okay. Then question number 9. If sodium nitrate is completely dissociate into cations and anions, so sodium nitrate is NaNO3. It completely dissociates means it form Na plus and NO3 2 minus. So total I is equals to 2. The change in freezing point delta TF, so delta TF is equals to I KFM, this is the formula, is 0.05 moles. So moles is 0.05 and weight of the solvent is 1 kg. So formula is delta TF is equals to I, then Kf, I is 2, then Kf is given 1.86. A molality is like moles of solute divided by volume, like mass of solvent in kg, which is already given in kg. So whenever we multiply this, so we get 0.1860. So our answer is 0.1860. Okay, this is question number 9. Then question number 10. For the reaction A converted into B plus C, when a student X double the concentration of A, the rate of reaction was found to increase by 8 times. The unit. Okay, so rate of reaction is equals to K A to the power N. Okay, uh, from this equation we found out the like order of the reaction. Then given that rate of reaction increases 8 times, so 8 ROR is equals to K if the concentration of A is double. So it will be 2A power N. Now we will divide ROR into K into A to the power N. Okay, whenever we divide ROR cut by ROR, K cut by K, A to the power N cut by A to the power N. So we get 8 is equals to 2 to the power N. Now we can write 8 as a 2 to the power 3. So 2 to the power n. So n is equals to 3. Okay. So the order of the reaction will be 3. Okay. Now, what is the question? The unit of rate constant. So the unit of rate constant K is equals to mole per liter 1 minus n, where n is the order of reaction and the second inverse. Okay. N is 3 we found from the equation. So mole 1 minus 3 is like minus 2 divided by liter power minus 2 second inverse. Okay, and then liter goes up, so become K is equals to mole minus 2 liter plus 2 liter to the power square and liter square and then second inverse. So option number C is the correct answer for the question number 10. Okay. Then question number 11, which of the following combination is incorrect? Okay. So there is not such a relationship between molecularity and order of reaction for like reactions, complex reaction. For the elementary reaction, molecularity and order will be safe, but there is no such a relation for the complex reaction. Okay. Now, the second thing, molecularity is the theoretical value. It could be only 1 to 3, not fractional, not 0. Here, molecularity is given as fractional. So, this is incorrect. Okay. Now, which of the following reagent both react with glucose and fructose will produce the same product? Okay, so here phenyl hydrogen is the reagent. This is like a understanding question which is already did in biomolecules. What kind of bond form with glycine? Glycine is amino acid and alanine, which is also amino acid, and two amino acid bonded together by a peptide bond by a peptide bond. So answer will be peptide bond. And protein also are called as polypeptides because they have multiple peptides bond. Okay. Now what is deuter ion? So the ion which contain both positive and negative charge like RCH, NH2 and COH. Now this H plus goes here and it convert into RCH, NH3 plus and COOH minus, COO minus. This is a deuterium. Okay. Glycosidic linkage found in the starch and coordinate bond. This is a dative bond. Okay. Then next question, the reaction of A. A react with ammonia, form B. Okay. And then we treated with HNO3, HNO3, okay, form diazonium salt, and this diazonium salt again give A. Okay, diazonium salt again give A. Okay, so what is A? Now this is like a kind of question where B is aromatic amine. So you can also eliminate from the option. So this is chlorobenzene, phenol, chlorobenzene and amine. So option will be this like correct. Otherwise you want to do the question. So A will be C6H5Cl which react with ammonia give aniline. Okay, aniline after removal of HCl, and then this aniline react with nitrous acid HNO2 and give us diazonium salt, and this diazonium salt again converted into chlorobenzene with the liberation of nitrogen gas. Okay, so option number D is correct. Then question number 15, Rahul want to prepare chloroform in the lab using ethanol, the correct order. So the lab method in the chloroform. First step, we use bleaching powder and this bleaching powder liberates Cl2 gas. Okay. Now this Cl2 gas react with C2H5OH and act as oxidizing agent and convert into CH3CHO like in the form of acetaldehyde. Then this acetaldehyde after chlorination convert into CCl3CHO and this CCl3CHO react with COH ka whole twice and give us CHCl3. This is the reaction. So the first step is liberation of chlorination, second step is oxidation, third is chlorination and fourth is hydrolysis. Of course, basic hydrolysis. So option number B is correct. The bond length in the haloarenes is shorter. This is the haloarene and this bond length is shorter compared to this like technically. So this is sp3 carbon and this is sp2 carbon. Sp2 carbon is technically more electronegative carbon. Okay, other reason is because of resonance this bond length is completely shorter. Okay, so there is two reason, one is sp2 carbon due to sp2 carbon and the other reason is due to resonance. Here mention is resonance, so we took that option. So due to resonance, CX bond length is shorter. Okay. Then question number 7, how many charges required to reduction of 1 mole of Cu2 plus into Cu? Okay. So 1 mole of electron require 1 Faraday electricity which is equals to 96500 coulomb. Okay. 96500 coulomb. Now Cu2 plus convert into Cu, it accept 2 electrons. Okay. So it required 2 mole of electricity. 2 mole means 2 mole Faraday 96500 and whenever we multiply by this so we get 193,000 coulomb. Okay, then this is the question. NaCl, the above graph indicate the variation of molar conductivity of different electrolyte NaCl, CH3CO, KCl represent 1, 2, 3 respectively. The order of increase in molar conductivity. So the second have less conductivity because it is a weak electrolyte. So weak electrolyte have less conductivity. After second, K plus ion is a larger size compared to Na plus ion. Okay. So Na plus ion have higher conductivity. So after, first will have higher and then third will have like in between. Okay. So this is lowest, then this, and then this. So two third one. Two third one is the order. Okay. Two third one is the order in the general perspective. Okay. Now, if we notice the graph, if we notice the graph, so in the graph, the conductivity is given. Okay, the concentration is given and the molar conductivity is given. So which one will have the higher conductivity? The first one. Okay, and after the first one, the second one, and after the second one, the third one. The conductivity points. Okay, from the graph. So it will be first, second, third. So it will be first, second, third. Okay, first, second, third, like opposite order. So third, second, first. So option number C, third, second, and first. Okay. Then on adding silver nitrate solution with COBr2 Cl4NH3 1 mole of light yellow PPT. Light yellow PPT is like AgBr. Is of compound X is obtained. X is AgBr. Which of the following statement is true? So we want one like Br outside the bracket. So COBr, then Cl, then NH3 whole 4 and Br. This is the complex. It react with AgNO3 and form AgBr. Okay. So this is the primary valency and this one is the secondary valency. So primary valency of chlorine, cobalt here is plus 3 and this primary valency will satisfied by this primary valency will satisfied by. Okay, sorry. Light yellow PPT is AgCl. So we have to remove Cl outside and Br inside. Okay, so this become AgCl and this primary valency satisfied by one chlorine atom linked by primary valency. Okay, got it? Then question number 20. Gia applied magnetic field to the this and this compound. She found that it strongly attract towards magnetic field. That means this is a paramagnetic compound and this is the diamagnetic compound. That is C. Okay, Cn is a weak field ligand. No, Cn is a strong field ligand. H2 is a weak field ligand. Yes, H2 is a weak field ligand. Fe2, H2 is the inner out orbital complex. No, generally, if we form the complex, it will be like Fe2 plus. So it will be 3d6. Okay. So 3d6 is like 1, 2, 3, 4, 5 and 6. Okay. 5 and 6. Now, we want S4S, 4P and 4D. So hybridization will be sp3d2. So technically this one is sp3d2, which is a outer orbital complex, not a inner orbital complex. So this statement is also incorrect. Now, a strong field ligand have low spin, okay, and weak field ligand have high spin. So this statement is correct. So Q and S is correct. Okay, Q and S is correct. So option number D, Q and S is correct. Okay, now the question number 21, toluene react with chromyl chloride. Chromyl chloride is CrO2Cl2. In the presence of CCl, give compound A, X. Which of the following test is most likely to be shown by compound X? So this is toluene. It react with CrO2Cl2 in the presence of CCl4. It gives benzaldehyde, and this reaction is called as this gives benzaldehyde, okay, aromatic benzaldehyde, and this reaction is called as Itard reaction. And then aromatic benzaldehyde gives tolerance test, okay. So it gives silver mirror tolerance test, whereas aliphatic aldehyde give both Fehling solution test and tolerance test, but aromatic aldehyde only gives tolerance test. So the correct option will be C, silver mirror by tolerance test. Okay, aromatic aldehyde gives silver mirror test by Tollens. Okay, silver mirror test by Tollens reagent. Okay, what is Tollens reagent? So tolerance reagent ammonical silver nitrate. Okay, ammonical silver nitrate. This is tolerance reagent. Okay, ammonical silver nitrate. Now, next question, which of the following compound is most and least reactive towards nucleophilic substitution reaction? Okay, so nucleophilic substitution reaction most likely directly proportional to minus M and minus I group, inversely proportional to plus M and plus I group. So firstly we have acetone. Acetone is this CH3COCH3 where we have 2 plus I groups. Okay, 2 plus I group. Then we have benzaldehyde. Benzaldehyde is this one. Okay, and then we have formaldehyde. Formaldehyde is this one. Okay, and then we have acetophenone. Acetophenone is this one. Okay, so here we have one plus I group, and this is also involved in the conjugation with ring. Okay, so it is like least, it will be least because the like bond is busy. Okay, so it will be least. Okay, now what about the most? So most reactive will be this one. Okay, so formaldehyde will be most reactive, and then this acetophenone will be least reactive. So 3 and 4, 3 and 4, 3 and 4. So option number A. Now question number next 23. When a plot with of rate at y-axis, this is rate at y-axis and concentration at x-axis, a student conclude that the order of reaction is zero. What must be the observing graph? Okay, for the zero order reaction, rate of reaction doesn't depend on the concentration. So it will be like a parallel line with x-axis. Okay. Then next is the assertion reason question. The first question is electrophilic substitution reaction in haloarine take place in ortho and para position. The major product is para substituted. Okay, so if it is haloalkane, so it acts as plus M group, and plus M group activate the ortho and para position, which is the correct statement. So A is correct. Now, the halogen in the ring is not ortho para directing. No, if it is ortho para directing, so the second statement is false. So A is true and R is false. Okay, so option number C is correct for this question. Then for question number 25, benzaldehyde on the nitration give ortho and para-benzaldehyde. So benzaldehyde is this, and this is CHO. CHO is actually a minus M group which activate the meta position. So technically it gives meta nitrobenzene. So first statement is incorrect. Now CHO group at in the benzaldehyde act as minus I group. Okay, CHO is also a minus I group as well. And benzene ring for the CHO act as plus R or plus M group. So in the respect of this act as plus R or plus M group, which is also correct. So A is false and R is true. A is false and R is true. Okay. Now next is the half-life period of the first order reaction does not depend on the initial concentration. So formula is T half is equals to 0.693 by K. So of course it doesn't depend on the initial concentration. So statement first is correct. Then the initial reaction expression is present in the expression for the rate constant. No, it is incorrect. So A is true, R is false. Then question number 27. Question number 27. Ethanol is less basic than water. That is correct. Okay, all the alcohols are less acidic than water except methanol. All the other alcohol are less basic. So that is correct. The electron releasing inductive effect. So C2H5OH act as here plus I group, which is decrease the acidic character. So it is also correct. So A is true, R is true, and R is the correct explanation of A. So for the 27, it will be A. Now for the 28, nucleic acid are present in all living cells. Yeah, it is present in all prokaryotic, eukaryotic cells, all living things. Okay, so it is yes, and then the They are not responsible for the passing the genetic information from the parent cell to new cell. No, this is the work of nucleic acid. They do. They pass the genetic information from the one generation to other generation. So R is true. A is true. R is false. Sorry, R is false. A is true. So the for the question number 28, C is the correct answer. Next portion of this is filling the blanks. Okay, so the first question is the orange color of dichromate solution change into yellow on the heating with alkali due to the formation of dichromate convert into chromate. Okay, so this is chromate. Then the pK of orthonitrophenol. Okay, the pK of orthonitrophenol is more or greater than paranitrophenol because its acidic character is lower. Okay, so pK is inversely proportional to acidic strength, and paranitrophenol is more acidic than orthonitrophenol because of intramolecular hydrogen bonding. Okay, so acidic character of orthonitrophenol is lower than paranitrophenol. Then amines do not um, tertiary amines do not undergo acylation because it doesn't have any hydrogen. Okay, any hydrogen. So they are not because they have like they lack replaceable hydrogen. So they do not undergo acylation. But because primary amines have two hydrogen and secondary amines has one replaceable hydrogen, so they do acylation. Okay. Then the next question, the want half factor for the acetic acid is greater than 1. Okay. In aqueous acetic acid, it is greater than 1 because it will dissociate into their ions. Acetic acid dissociate into their ion, but in the benzene, it doesn't dissociate. So it is less than 1 or it is less than 1. Okay. Because in aqueous solution, acetic acid dissociated into their ions. The first order reaction of uh, half complete in 20 minutes. So you have to tell the 75% completion and 87.5% completion. So for this reaction, I'm doing here. Okay. So T half will be equals to 0.693 by K. So K will be 0.693 by 20. Okay. Now for the 75 I am doing. So T is equals to 2.303 by K into log, okay, into log A not by 80. Okay. So 2.303 K is 0.693 multiplied by 20 and then log A naught is 100 and it will convert as 75. So leftover is 25. So 25 fours are. So it will be log 2 to the power 2. So it will be become 2.303 into 20 upon 0.693 into 2 to log 2 to the power 2 like 0.3 multiplied by 2 is become 0.6. So it will be 2.303 into 20, 0.6. It is always 0.6. So it approximately 40. Okay. So 75% percent of the reaction will converted approximately 40. Now instead of 75, we have to put here 85.7. So 100 minus 87.5 become 5 and 2 and 1 12.5. So it will be like log 100 by 12.5 which is actually 1000 by 125. It will be 5 and then it will be like 8. Okay, so it will be like 8. So it will be like 2 to the power 3. So 3 into 0.3 becomes 0.9. Okay, so the value is 0.9. So 2.303 multiplied by 20 multiplied by 0.9 divided by 0.6, it will be like 0.2, 0.3. Okay. So whenever we multiply this, so approximately we get uh, 2 twos are 2 threes are 6. So approximately we get 60. Okay. Approximately we get 60 minutes. Okay, you can calculate it. Then the next question is fibrous protein are fibrous proteins are insoluble in water, whereas globular protein are soluble in water. Okay. Then elimination reaction haloalkane presents in the take place of alcoholic KOH. Okay, and it will give a beta position. Okay, at the beta position. Now, when the concentration of solution of weak electrolyte lowered, okay, decreases or lowered, its molar conductivity, its molar conductivity increases. Okay, the melting point of acetic acid is more than propanoic acid. Okay, the melting point of acetic acid is more than propanoic acid, but the boiling point of acetic acid is less than propanoic acid. Then the complex ion, this is the complex ion, and both have a ambidentate ligand. So this is a linkage, and because nitro group is more stable, that's why this is more stable. Okay, so the complex ion CONH3 5NO2 2 plus is more stable towards an acid than CONH3 5O NO 2 plus, and this type of isomerism shown in is called as linkage isomerism. Then the next question is very short type question. So the very first question, the boiling point of methylamine, ethane and methanol is 265 Kelvin, 185 Kelvin and 333 Kelvin respectively. How can you account for these boiling points? Okay. So if we have to explain this, so a boiling point directly linked with hydrogen bond. Okay, because in these methanol have highest boiling point because methanol have hydrogen bond and ethane doesn't. Ethane neither have any hydrogen bond and ethane is non-polar, so it have least. And then amines also have hydrogen bond. Okay, but hydrogen bond is directly proportional to electronegativity because oxygen is more electronegative than nitrogen. That's why it have highest boiling point, then amines and then methanol. Okay, so hydrogen bonding is the phenomenon for the boiling point. Okay, so I'm explaining this question and you can write the answer as you want, like this way, at that way. Okay, so do you think CO En thrice 3 plus will show optical isomerism? If yes, draw the possible isomers, name the following. Okay, if no, explain why. So firstly, we want CO. Okay, this is a octahedral complex and I'm drawing this octahedral complex En, and En here. Okay, so this bond here, this bond here, and this bond here. Okay, so this do form a optical like optical isomers. Okay, and their mirror image like this way. So, okay, and they form two uh, form of optical isomer. One is D form and other one is L form, dextrorotatory and levorotatory. Okay, then next question. Based on valence bond theory, discuss the hybridization shape and charge on the NiCO3, no, CO4. Okay, so here the oxidation state of Ni is 0 and the last electronic configuration is 3D8 4s 4s 2. Okay, so it become like 3D10 and then we have coordination number 4. So it will be 4s and 4p. So we want one s orbital and 3p orbital. So hybridization will be sp3 and sp3 hybridization have okay, hybridization is sp3, then sp3 hybridization with 4 bond is tetrahedral because there is no charge, so charge will be 0. Do you think charge on copper metal will be same? No, copper metal have different charge. Okay, okay, yeah. For here, copper metal also have same charge. Copper metal also have zero charge. because CO is a compound carbon monoxide, okay, which is in the coordination we say that adds carbonyl, okay. So it doesn't have charge. That's why CO is also a zero charge. Then the next question, two students X and Y were studying about the basicity of the compound. X wrote that ammonia is less basic than methylamine, okay, and whereas Y wrote that ammonia is more basic than methylamine. So this is methylamine and this is ammonia, okay. Basic strength is directly proportional to plus M and plus I group, and here we have plus I group, okay. So that means it is more basic. Methylamine is more basic than ammonia, okay, due to the plus I group, okay. So X is right, okay. X is right. X is correct, okay. Then next question, our student has carried out a suitable test for differentiate between ethylamine and diethylamine. Okay. So for ethylamine and diethylamine, we can do the carbalamine test. Okay. Carbalamine test where ethylamine will react. Okay. And give a pungent smell of carbalamine treated with CHCl3 and alcoholic KOH, where diethylamine doesn't react with that. Okay. Then we have ethanol and ethylamine. So ethanol give iodoform test. Okay. And you as know iodoform, whenever we treated ethanol with I2 and KOH, it gives yellow PPT of CHI3 iodoform. Okay, so it give iodoform test, but ethylamine doesn't give the iodoform test. So these the for the differentiation between ethylamine and diethylamine, we use carbalamine test, and for the iodoform for the ethanol and ethylamine, we do the iodoform test. Okay, for that we do iodoform test. Got it? Okay. So only 1 degree amine gives carbalamine test. Okay. So I'm just writing this carbalamine test C2H5NH2 react with CHCl3 in the alcoholic KOH. It will give CH3CH2NC NC, which is isocyanide or carbalamine. Okay, which have pungent smell, okay, or rotten egg kind of smell, plus 3 KCl and plus H2. So only primary amine give this test, okay. Primary amine and aniline give this test, okay. Whereas diethylamine doesn't, okay. So 2 degree amine doesn't give this test, okay. Got it? And this ethanol and ethylamine, so ethanol CH3CH2OH react with I2. Firstly, it acts as reducing agent, so it form chloroform, iodoform, and iodoform is yellow PPT. So ethanol give that test, ethylamine doesn't. So from the carbalamine test and haloform test, we differentiate these two substances. Okay. Then we have question number 44. Give the reason for each. Except glycine, all other naturally occurring alpha amino acid are optically active. Why? Because glycine is unsymmetrical. Okay. So glycine is symmetrical and all other are unsymmetrical. So this is G, then CH, NH2 and COH. This is the primary so for the glycine it becomes CH, G become H and NH2, which is not a optically active carbon, but other all the optically active carbon. So that's why glycine doesn't like except glycine, all other the optically active. Deuter and also known as dipole, and because if we have RCH NH2 COOH, it releases H plus and accepted by NH2, so it become RCH NH3 plus and COO minus. Okay, So because deuter ion have both positive and negative ion, positive and negative charge or cations and anions, that's why it is called as a dipolar ion. Thank- Then question number 45 complete. Okay, so this is glucose, and glucose react with HI and give hexane. Okay, HI is a good reducing agent. It will reduce all the groups and it will convert it into hexane. Okay, normal hexane. Now enzymes are known as biocatalyst. Why? Because they used or they produce in cell. Okay, they produce in cell and catalyze the reaction involving the like living things. Okay, so they are called as biocatalyst. Now this is the graph. If this is rate and this is concentration, both are increases, that means it is a first order reaction. Okay, it is a first order reaction. This is the graph thing, so it is a first order reaction. If graph is given that way, so this is a zero order reaction. If graph is started from this way, it is a first second order reaction, like that way. Okay, now find the 3/4 life of a first order reaction. Okay, find the 3/4 life of a first order reaction. So we have to find 3/4 life. So it will be equals to 2.303 upon k is 7.4 into 10 to the power minus 5. Let's assume initial concentration is A. Initial concentration is A. So A converted into B. Initial concentration is A. If we and at the time it is 3 by 4A. Okay. So A minus 3 by 4A. A minus 3 by 4A. So it will be like 4A minus 3A upon 4. So it will be A minus 3 by 4A. So it will be A minus 3 by 4A. Okay. Let's assume the initial concentration is 1. Okay. So it is 3 by 4. Okay. So 1 minus 3 by 4 become 4 minus 3 by 4. It is like 1 by 4. So the leftover is 1 by 4. So 1 by 4, which is equals to log 4. Okay. Directly log 4. And log 4 is like 2 to the power 2. So log 2, value of log 2 is 0.3 multiplied by 2 is 0.6. So T 3 by 4 is equals to 2.303 divided by 7.4 into 10 to the power minus 5 into 0.6, and whenever we solve this we get um 0.23 37. So we get approximately 1.787 into 10 to the power 4 second. Okay, so time is 1.87 into 10 to the power 4 second. You can do the calculation portion once again. Okay, so if the initial concentration is 1 and we have to convert 3 into 4, so 80 become 1 minus 3 by 4, which is equals to 1 by 4. If you remember, this is a chemical kinetic activation energy graph. Okay, this is activation energy graph, where A is potential energy. Okay, one is potential energy, two is reactant, and four is product. Because product have more energy than reactant, so process is exothermic. Okay, process is exothermic, and this is reaction coordinate, and the three is activation energy. This is the graph. Okay, for the exothermic process. Now next question. Rohan arranged three calorimeter in the series and passed 1 Faraday of charge. Define time of three electrolytes shown. Okay, first is HCl, other one is AgNO3 and then CuSO4. HCl convert into H plus Cl minus, AgNO3 convert into Ag plus NO3 minus, NO3 1 minus and Cu 2 plus and SO4 2 minus. Okay, if their electricity, what is the ratio of numbers of moles of positive ion liberate on the cathode? So here 1, 1 and here is 2. Okay, so it is 1 ratio 2. If we pass 4895 coulomb of charge through the electrolyte, how many gram equivalent of copper? Okay, so 1 gram equivalent of copper, 1 gram equivalent of copper equals to 96500 coulomb. Okay, so X will be equals to uh, 4825. Okay, so 4825 divided by 96500 becomes 0.05 gram equivalent. So answer will be 0.05 gram equivalent. Okay, 0.05 gram equivalent. Okay, got it? Then the next question, question number 50. Yes, measure the conductivity of two different solution of 1 m of ethanoic acid and 1 m HCl at 25 degrees Celsius. Will he observe the same conductivity? No, because it is a strong electrolyte and it is a weak electrolyte. So no same conductivity. Justify your answer. So because it is a strong electrolyte, so 1 m HCl have more conductivity than 1 m ethanoic acid because of a strong acid. It is a strong acid and this one is a weak acid. So strong acid act as a strong electrolytes. Okay. The second question, what will be effect of conductivity when he keeps diluting the solution? Okay. So whenever he keeps diluting the solution, the conductivity, the concentration and the molar conductivity. So the conductivity of HCl is like linearly, but the weak electrolyte will be like this way. Okay. Then the next question, the standard reduction potential for the following electrode is given below. Answer the following question. Which substance could be convert iodide into iodine? Okay, iodide is -1 into iodine. Like we want a oxidation process, so we want a oxidizing agent. Okay, so we have to check the reduction. Okay, where reduction will take place. Okay, so the oxidation potential of iodine will oxidize. Iodine will oxidize. So which one? All of them have, okay. Which one have higher reduction potential than iodine? It is this one, Ag plus. Okay, it have higher potential. Okay, higher reduction potential. Now tell me the reaction from the given reaction which is spontaneous. Fe2 plus Ag. Okay, so Fe2 plus reduces. Okay, Fe2 plus reduces. So the reduction potential, which one have like lowest reduction potential? So it is Mg. So Mg can reduce. Okay. So second one will be spontaneous. Okay. Second one will be spontaneous. Question number 52 is from the organic compound given below. Acetone and it is benzaldehyde and benzophenone. Arrange the following compound in decreasing order of reactivity towards SCM. Okay, so acetophenone is this one. Benzene ring with COCH3. Benzaldehyde is this one. And the last is benzophenone. Benzophenone is this one. Okay. Now let's talking about the groups. Okay. So this is one group, here we have two groups, and here we have three groups. Okay, these two groups increase the steric hindrance. Okay, these two groups increase the steric hindrance to here, these two groups increase the steric hindrance to here, but here is only one group which increase the steric hindrance. So in between these three, second one will be most reactive. After second one, the first one, and then after first one, the third one. This is the reactivity order. So benzaldehyde is most reactive towards SCM, then our acetophenone, and then our benzophenone. Now next question is give a chemical reaction when compound 1. Compound 1 is acetophenone. So this is the acetophenone COCH3. React with compound 2. Compound 2 is benzaldehyde. This is CHO. Presence of dilute alkali like dilute NaOH. So it is like aldol condensation. So we have to form aldol product. Okay, this reaction is aldol condensation, and we have to form aldol. Now, the first compound I'm writing this way COCH2H. This is our alpha hydrogen, so it become negative and this become positive. Okay, and the presence of alpha hydrogen give us aldol condensation. The second reactant I'm writing this way C double bond O and then H. Okay, this bond break in this way negative and positive. So we get benzene ring, then CO, then CH2, and then this CH2 directly attached with this CH, here the OH, and here the benzene ring. This is our aldol. We can also write it like this way: benzene ring C O CH2 CH OH and then benzene ring. So this is our aldol. Okay. And now if we if we heat this, okay, so it will give us alpha beta elimination. So this is like our alpha carbon and this is beta carbon. So we get this product CO CH double bond CH and then removal of H2O take place here. So we get this is our final product after removal of H2O. Then question number 54 is D block element exhibit large number of oxidation state than F block element. This is the reason because the energy gap in d orbital not much. Okay, so they can easily remove the more electrons and they give multiple number of oxidation state, but there is large gap of energy in F block. Okay, that's why they do not have like more oxidation stable number. Okay, now then increase in atomic number does not change atomic radius among the transition element. So if we have this scandium, titanium, vanadium like this way, so increase the atomic number does not change in atomic radius among the transition elements. Why? Because they have like this configuration n minus 1 d 1 to 10 and then NS2. So NS2 or NS1. So outer orbital configuration is same for all the d block elements in the same period. So they do not have like a different number of outermost cell. That's why they do not change their atomic radius so much in the like any certain period. Okay, they do change slightly, but not so much because of this configuration. Okay, now question number 55 highlights of transition element in higher oxidation state are more covalent. Okay, so if I'm taking a transition metal M and we form halide like MX2, MX3, MX4, so the oxidation state of a metal is here M2 plus, M3 plus, M4 plus. This is higher halides. Okay. This is like here oxidation state is 4. Now, according to Fezan's rule, phi is directly proportional to charge on cation. And the cation will, if charge on cation increase, the phi increase, and if phi increase, the covalent character also increase. So, according to Fezan's rule, if the oxidation state of uh, metals of D block elements increases, so their covalent character increases. Then question number 56 is write the equation of the following observation. The first observation is potassium permanganate. Potassium permanganate is KMnO4. With potassium iodide is Ki in acidic medium, so we took H2SO4. release iodine gas, that is I2, and water, that is H2O, and the sulfate of potassium like K2SO4, and manganese like MnSO4. Okay, give the balance equation. So we have to balance this equation. Okay, so oxidation state change of iodine is here. Iodine is here -1 to 0, and the reduction change is here is +7 to +2. Okay, so we have to multiply by 5 to here. Okay, and uh, 1 to other side. Okay, so whenever we multiply by 5, here is 1 I, here is I2, so it will be like 5 I2, and where here we have to took 10 Ki, because 1 I, Ki contain only 1 iodine. Now in the KMnO4, for the balancing reaction we have to multiply by 2 plus 10 Ki, and then here it become like 2 MnSO4 plus K2SO4. Now we have water as well. So here it 8 water and 10 CO2. Now for 8 water we have to write 8 H2SO4. So this is the balanced chemical reaction. 2 KMnO4 plus 10 Ki plus 8 H2SO4 give us K2 2 5I2 2 MnSO4 K2SO4 8 H2O 10 CO2. This is the first reaction. Now I hope you wrote the reaction. Then the second reaction is potassium permanganate. Potassium permanganate is KMnO4. I'm now directly balancing here. React with oxalic acid. Oxalic acid is COOH. COOH. React with, in acidic medium we took H2SO4. This is the reactant. Product is, give salt of potassium K2SO4 plus salt of manganese MnSO4, and then release water molecule plus carbon dioxide. Now, for the here we have to took two here, 5 here, the same pattern. Here we have 3, and then 1 K2SO4, 2 MnSO4, 8 H2O, and 10 CO2. This is the balanced chemical reaction for the part 2 of 56 question. Question number 56, part 2 have this answer. Okay. Now question number 57. What mean of hydroboration oxidation reaction? Explain with the equation so the final product formation. Okay. So hydroboration oxidation is like we firstly do the boration. Okay. So I'm taking a simple alkene CH3 CH double bond CH2. This simple alkene firstly react with BH3 in the presence of THF. We also took B2S6 because of less stability of BH3. Then we get this product CH3 CH2 CH whole thrice B. This is hydroboration. Now, the hydroboration oxidation HBO give us anti-Markovnikov alcohol, so it becomes CH3, CH2, CH2OH. So this is our final product for the like reaction follows the Markovnikov mechanism, but final product become the anti-Markovnikov alcohol. Okay. Now question number 7. Arrange the following in the increasing order of their acidic strength. So we have phenol. This is phenol. Then we have 4-methylphenol OH, and 4-methyl is like CH3. And we have 3-nitrophenol. Okay. So the acidic strength is directly proportional to minus M group, inversely proportional to plus M. Directly proportional to minus I, inversely proportional to plus I. Here CH3 is plus M or plus I group, which technically decrease the stability of like decrease the acidic strength, and NO2 here is minus I, not minus M, because mesomeric effect doesn't operate on the meta position. Okay, so it directly proportional to acidic strength. So it is, if it is 1 to 3, so 3 will be more acidic. Okay, nitrophenol will be more acidic. After that we have second, and after that we have first. No, after third we have first. Okay, because without any group, and plus M or plus I group decrease the acidic strength. So after first it will be second. Okay, after first it will be second. Number 58 is you are provided with KOH, aqueous and alcoholic Cl2, HBr acidified, K2SO4, NaOH, and soda lime. Using this reagent, carried the following conversion. Okay, so we have to solve. We have to do following conversion with the help of this. Okay, so alcoholic KOH give alpha beta elimination, aqueous KOH give nucleophilic substitution. Then HBr will add, this will goes chlorination. This will give us a chlorination. Now K2Cr2M4 act as oxidizing agent. NaOH and soda lime act as decarboxylation. Decarboxylation. They do decarboxylation. Okay. So we have to prepare propanoic acid to ethanol. So propanoic acid is this one. Propanoic acid is this one. CH3CH2COOH, and we have to prepare this CH3CH2OH, which is ethanol. Okay, so firstly we do the we react with NaOH, we get CH3CH2 COONA acid base reaction. Then this react with soda lime. Soda lime is technically a mixture of NaOH and CaO, and this give alpha beta elimination, and we get C2H6, okay, after removal of CO2. And then this C2O6 after chlorination give us CH3CH2Cl. This CH2CH3Cl react with aqueous KOH, which give us substitution reaction, and we get our product CH3CH2OH. Okay, so firstly we use NaOH, then soda lime, then Cl2, and then aqueous KOH. Okay, then aqueous KOH. This is our first conversion. The second conversion is chloropropane. Chloropropane to propanol. Chloropropane is this one. CH3, CH2, CH2Cl. Okay, so firstly we react with alcoholic KOH, which give us alpha beta elimination like CH3, CH, double bond CH2. Now it treated with HBr, so we get Markovnikov rule CH3CH2 bromopropane, and then we treated it aqueous KOH, which give us substitution reaction, and bromo group substituted by OH, and we got true propane 2 all. Okay, so firstly alcoholic KOH, then HBr, then aqueous KOH. This is the reaction. Next question, what is the significance of want of factor? So there is two significant. Firstly, derive the relationship between derive the relationship between actual and theoretical molecular mass. Or secondly, to determine the correct molecular mass which undergoes dissociation or association. Okay. The second question is devise the basically it is derive the relationship between want of factor and degree of dissociation for the aqueous sodium solution of barium chloride. Barium chloride is BaCl2. It will convert into Ba2 plus and 2Cl minus. Total number of dissociation it is, if it is alpha, okay, it is alpha, so it is alpha and it is 2 alpha. Okay, so I is equals to 1 minus n by I, okay, sorry, by 1. So 1 minus n is total alpha. This is plus 3 alpha. By 1, it become 1 minus 2 alpha. So this is the want of factor. Okay, we simply derive it from the formula. Then next question is observe the observe the following diagram and answer the following question. Okay, so this is took a 1 m 0.1 m glucose solution, and this is 0.1 m solution. Okay, and this is semi-permeable membrane. Here this concentration of the solution is 0.1. Here the concentration of solution is total number of ion is 0.1 plus 0.1, because NaCl dissociate into Na plus and Cl minus. Okay, so um, which will have direction of flow or solvent which will take. Okay, so it is, if it is A and it is B, okay, it is given as A and B. So because it have high number of moles of solute, okay, it have high numbers of mole of solute, so the movement is from the compartment B to compartment A because of I. So total numbers of ion here is zero point 0.1, but here is total number of ions is zero point 0.2 because of dissociation. So I become 2, here I become 1. Okay. So the movement of flow of solvent will be from the higher concentration to lower concentration, and solution we have higher concentration. So movement will be from B to A. And then infer on which compartment pressure should be applied to stop the flow of solvent. So where the flow can take place and at there. So we have to put external pressure on the solvent A. Okay. So we have to put the external pressure on the compartment A. Okay. And that external pressure is called as osmotic pressure. So the pressure which required to stop the osmosis process is osmotic pressure. Okay. Now the next question is 2.517 gram of naphthalene is dissolved in 15 gram of CH2 carbon disulfide. The solution boil at 319.70 Kelvin and the boiling point of CH2 is 319.4. Calculate the molar mass of naphthalene. Kb of this is 2.34. So formula is delta Tb is equals to Kb into m. And uh, that is elevation in boiling point, which is 319.70 minus 319.4 is equals to Kb is Kb. M is given weight of solute upon molecular mass of solute multiplied by 100, and here molecular weight of, sorry, multiply by 1000, here molecular weight of solvent. Okay, so we put the value of Kb, which is 2.34, into given weight of naphthalene is 2.517, and multiply by 1000, and the molecular mass of solute, molecular mass of solvent, we have to calculate. So this is Mb, and given weight of solute is 150 gram. So whenever we solve this, here we get 0.3, and the multiplication, so Mb become 2.34 into 2.517 into 1000 divided by 150 into 0.3, and whenever we solve this we get around 130.8. Okay, solve it and you get 130.8. So the molecular mass of naphthalene is 130.8. Then the next question is, given below are the two types of mechanism. Okay, so this is pathway 1 and this is pathway 2. Okay, so as we see here, this is pathway 1. It is a SN1 mechanism, okay, which take place in two step, and it is SN2 mechanism which take place via a transition state. Why is the product A is pathway is optically active? Because here uh, inversion take place. Okay, inversion take place. That means it will attack on the opposite peak. Okay, so because of inversion take place, we get the optically. Okay, so this is okay. In the B, inversion take place. Okay, so inversion is optically active, but A, the pathway of A is optically inactive because nucleophile attack on the same side. Okay, so there is no inversion in S11, so that's why it is optically inactive. The investigate the effect of plain polarized light on the product B, because it is a chiral carbon and the OH group attack on the opposite plane, so it will be optically active. So if it is optically active, so it will rotate the plane. Okay, it will rotate the PPL, plane polarized light. Okay. Okay, now which one will be faster? So the stability of carbocation will be faster. So the pathway of A, like SN2 reaction will be, sorry, SN1 reaction will be faster than SN2 because of here we have the heavy groups. Otherwise, here we have more stable carbocation. 3-degree carbocation is more stable carbocation. So pathway of SN1 is like A pathway is more faster than B pathway. Okay, so the next question is about short answer type question, and where the very first question is from the aldehyde ketone and carboxylic acid. This box given a list of aldehyde ketones. Choose the appropriate aldehyde ketone that react with CH3 MgBr, which is a Grignard reagent, form 1 degree alcohol, 2 degree alcohol, and 3 degree alcohol. Okay, so we have to form 1 degree alcohol, 2 degree alcohol, and 3 degree alcohol. For 1 degree alcohol, we have to took aldehyde. Okay, so this aldehyde we can obtain 1 degree alcohol. This is formaldehyde. Okay, so formaldehyde reacted with Grignard reagent CH3 Mg and Br. This bond break in such a manner carbon get negative and Mg get positive. This bond break, oxygen get negative, carbon get positive. So it will be like CH2 and this attach with CH3, this negative portion and the OMgBr. And then whenever we do the hydrolysis H plus and OH minus, so this bond break, sorry, not this bond break, we get CH2 OH and this CH3. So this is a 1 degree alcohol. Okay. So for the 1 degree alcohol, we want formaldehyde. Now for the 2 degree alcohol, we want at least acetaldehyde. Okay, acetaldehyde is like CH3, C double bond OH. Okay, it treated with CH3 MgBr. This bond break, CH3 get negative, Mg get positive. This bond break, oxygen get negative, carbon get positive. It become like CH3C, CH3, and then this H, and then O, MgBr. Okay, now we have to do hydrolysis. So H plus goes here, OH minus goes here. So it will be like CH3, CHOH, and CH3, a 2 degree alcohol. Okay. For a 3 degree alcohol, we have to took acetone, CH3CO, CH3, and then it react with CH3, MgBr. This bond break in such a manner that carbon get negative, magnesium get positive, and this bond is like this way, oxygen get negative, carbon get positive. It will be CH3C, CH3, and CH3, and this OMgBr. Now we do further hydrolysis. Oxygen get negative and Mg get positive. Mg attach with OH negative and oxygen with hydrogen. So we get CH3C, CH3OH, CH3, which is a 3 degree alcohol. So for a 1 degree, we want formaldehyde. For a 2 degree, we want acetaldehyde, CH3CHO. Okay, and for a 3 degree, we want CH3COCH3, a keto. Okay, a keto. Now about the question number 64, it is from the alcohol phenol ether. The question is given the reason the K of p nitrohydroxybenzene. P nitrohydroxybenzene is this one. P nitrohydroxybenzene is 6.9 into 10 to power minus 8, whereas for the orthonitrophenol is this one. OH NO2 is 6 into 10 to the power minus 8. Okay, so okay, we have to give the reason why it have less pKa compared to this, because pKa is inversely proportional to acidic strength. As we know, the acidic strength of paranitrophenol is greater than the orthonitrophenol because there is a intermolecular hydrogen bonding which technically associate this hydrogen and busy this hydrogen, and it is not easily to donate this hydrogen. That's why this have more uh, value of pK. Okay, this have more value of pKa. Got it? Or Ka is directly proportional to acidic strength, so it have highest. Paranitrophenol is highest, have highest value of association. Uh, Sorry, dissociation constant. So because of that, this is more acidic. Okay, so this is due to this group as well and the intermolecular hydrogen bonding. There is two factor. Okay, then aromatic ether are insoluble in dipolar compound because they do not have hydrogen bond. Okay, so for dissolving into a polar compound, compound should have compound should have at least one hydrogen bond. There is no hydrogen bond in aromatic ether, so they do not soluble in organic, like they do not soluble in dipolar compounds. The CO bond in ether are polar. Okay, so this CO bond in the ether, the electron of oxygen is 3.5 and the electron of carbon is 2.5. The difference is 1.0. So they are polar. Okay, but they are polar due to the electron differences. The next question mentioned the following statement true or false. Okay, so the observed order of basic strength is in ammonia is it is a 2 degree or it is a 3 degree. Okay, so the observe the actually the order of acidic strength is like technically acidic strength is directly proportional to plus I, inversely proportional to minus I. So it have 3 plus I group, okay, and it have 2 plus I group. So the most acidic will be this. Sorry, most basic will be this. The tertiary, so C2H5 whole thrice, and is most basic. Then C2H5 whole twice NH, and then ammonia. So the first statement is false. Other thing, it is talking about the normal strength, okay, not a aqueous solution. For the aqueous, 2 degree have more than 3 degree. So remember that point. And the second statement is plus I effect is maximum in the primary amine than tertiary amine. So this is also a false statement because if we draw the structure of primary amine like RNH2, secondary amine RNHR, and the tertiary amine R3N, so it have 3 plus I group. Secondary amine have 2 plus I group, and the primary amine have only one plus I group. So due to that, this statement is also incorrect. Now the next statement is NN dimethyl aniline is a stronger base than aniline. So this is aniline NH2, okay, and this is NN dimethyl, okay, CH3 CH3, okay. So this is plus I group, and as we know, plus I group increase the basic strength, so it is a true statement. So third one is true, and the first and second statement is false. Okay. Now about the question number 66. This is the in the box certain reasons are given in the form of clues. Okay. Identify the clue that complete the equation. Okay. So dehydrating agent, alkali dissolved in alcohol, primary amine, anesthetic, poisonous gas, salt, universal solvent. Okay, so the first thing we have this. Okay, the first thing we have this, so we have to make it a amine like RNH2 react with chloroform in the presence of KOH, of course, alcoholic KOH. Okay, alcoholic KOH, and it will give RNC, which is a poisonous gas. Okay, and then we have KCl. Okay, and then we have H2O, which is a universal solvent. So it is 1 degree amine. Okay, it is anesthetic. Chloroform used as anesthesia, so it is anesthetic. This is poisonous gas. Okay, this is dehydrating agent. Okay, and this is salt, and this is universal solvent. Okay, so this is the reaction, and then about the question number 67, a patient was given a certain amount of iodide 131 as a part of a diagnostic procedure for a thyroid disorder, given that the half-life of radioactive is 131 in 8 days. What fraction of initial 131 iodide would be present in patient after 32 days if none of the were eliminated through a natural body process? Okay, so this is kind of a first order reaction. Okay, so just do this. A patient was given a and then half life is 8 day. Okay, now we just divide how many half life it have in 32 days. So there is 4 half life. Okay, there is 4 half life in 32 days. So the equation become initial concentration. Okay, initial concentration divided by 2 to the power 4. Okay, and this become initial concentration is 1.16, like 1 by 16 into A naught. Okay. The second question is the potential energy diagram for a multi-step reaction is given below. Okay. And we have to do which step will be rate determining step. The slowest step is rate determining step. So this is the step first, and this is the step second. So as we know, the step second is having maximum activation is energy. So it is uh, a step determining, like rate determining step. And because rate determining step is slow step, so the this step is slow and this step is fast. So faster step is A to V. Okay. Then the next question is from the chapter chemical kinetics. Aman and Rohan were working on the kinetic involved the decomposition of hydrogen peroxide in the presence of iodide ion. Okay, so this is a kind of first order reaction. Okay, then they both had their respective hypotheses as follows. According to Aman, the rate will be affected by changing the concentration of hydrogen peroxide and iodide ion as iodide ion involved in the reaction. According to Rohans, the rate will be affected by changing in the concentration of hydrogen peroxide. So here is hydrogen iodide is catalyst. Okay, so the rate doesn't depend on the concentration of catalyst. So according to here two statement, Rohan is correct and Aman is incorrect. Okay, then this is the graph for the first order. This graph is correct. Okay, and for the first order, this graph is also correct. Okay, so fine, because iodide doesn't depend, it is a catalyst. Okay, so the concentration of catalyst doesn't depend on the rate of reaction. Okay, then what do you think whose hypothesis is correct and why? So we know that Rohan's hypothesis is correct. Okay, because catalyst doesn't, the concentration of catalyst doesn't depend the rate. Okay, and then do you think that half-life of this reaction will change if concentration of the hydrogen peroxide is reduced? So if we know that this is a first order reaction, and first for the first order reaction the formula for T half is equals to 0.693 upon K. This equation doesn't contain the concentration. Okay, that means no, because this reaction doesn't have the like have doesn't contain the initial concentration of the reaction. In a chemical reaction, two reactants take place. The rate of reaction is directly proportional to the concentration of one of them and inversely proportional to other of them. What will be the rate constant? Unit of rate constant. So if I'm just assuming that A and B are the reactants, so rate will be equals to K, A to the power 1 and B to the power, like it is inversely proportional. So B to the power is 1, like this way. So overall rate will be 0. Overall rate will be 0. So overall order, the order of reaction will be 0 here. Okay, because they okay, overall order is 0, and the formula for the unit of rate constant is mole per liter 1 minus n and the second inverse, because n is 0, so it will be like mole liter inverse and the second inverse. This is the unit. Okay, because it is a 0, the overall rate of reaction is 0, because the concentration of one reactant is directly proportional and the other reactant is inversely proportional. Then observe the structure of protein given below and answer the question. Which type of structure A and B? So A is alpha helix structure, which is formed in the secondary structure of protein, and B is a complex coiled structure which form in the quaternary, okay, which is a quaternary structure of protein. Okay, so A is secondary structure, B is quaternary structure. A is alpha helix and B is coil-like structure. Then how can these structure converted to primary structure? So we can convert it by the either by the pH change, or we can also convert it by a temperature change. So there is two type we can convert these into primary structure. Then how write a balance equation for D-glucose in the axis of phenyl hydrazine. So D-glucose is this one, COH, and the 5 carbon CH2OH, and this OH, H, OH, OH, H, H, OH, NH. This is D-glucose, and we react C6H5, NH, NH2. This is phenyl hydrazine. Okay, three molecule of phenyl hydrazine react here, and it will convert it into glucosazone. So CH, NH, NNH, C6H5, then C double bond N, NH, C6H5, and then the further carbon 1, 2, 3 as it is, and the last one as it is. And here H, OH, OH, H, HOH, and the ammonia gas here, and the water molecule. Okay, this is the reaction for the phenyl hydrazine. Then question number, okay, write the reaction. Okay, we use three molecule, and each time one molecule used. Okay, and this is known as glucosazone. The compound is known as glucosazone. Question number 70. Two students took a solution of same amino acid at different pH uh, and applied a potential difference to their solution. So this is a anion, okay, and this is a zwitterion. This is the zwitterion. So, what do you think which student will observe a potential difference 0 and why? So, student B observe a potential difference of 0 because Jupiter ion doesn't migrate under influence of, they are quite stable, okay, so they doesn't migrate under influence of electric field, so that's why B. What would you do in the order to get a positive observation? So we can change the pH, okay, after changing the pH we can observe, we can get a positive observation. So question number 70B. The graph given below shown the rate of enzyme catalyst reaction with temperature. Okay, this is the enzyme catalyst reaction. Why does the rate of reaction does decrease at high temperature? Okay, so at high temperature, the denaturation of protein take place. Okay, the denaturation of protein take place. That's why they decrease. The rate of reaction decrease at high temperature. Then about the question number 71, the molecular shape of NiCO4 is tetrahedral, while that NiCN4 is square planar. Justify the shape of two compounds. Because NiCO4 have sp3 hybridization and NiCN4 2 minus have dsp2 hybridization. Okay. CO is a strong field ligand. Okay. CO is a strong field ligand and CN also a strong field ligand. Okay, but here the oxidation state of Ni is 0 and here the oxidation of Ni is plus 2. Okay, so that's why. Find the oxidation of state in Ni in each complex. In first it is 0 and in second it is plus 2. The question number 72. Nandini want to electroplate her bracelet with silver. She gives a bracelet to an artist. After electroplating, she gets the information that 1.6117 gram of the metal is deposited when electric current of 0.2 ampere is passed over 2 hours. How will she make the confirmation that the metal deposit in silver by using data? Okay, so according to Faraday's law, uh, W is equals to ZIT. Okay, W is given as 1.6117. Z is atomic mass divided by valency multiplied by 96500. Current is 0.2 ampere and it passed 2 hours. 2 hours is like 3600 second multiplied by 2. Okay. Then we solve this. Valency of silver is 1. So valency is 1. So atomic mass will equals to 1.6117 into 96500 divided by 0.2 into 3600 into 2. And whenever we solve, atomic mass of silver, we get 108 gram here. Okay. So 108 gram of silver metal deposit here. Which law is applicable to solve this problem? So it is Faraday's law. Okay. Faraday's first law of electrolytes. This is Faraday's first law of electrolytes. Now the question number 73 from the haloalkane and haloarine chapter. 3-bromo 3-methyl-hexane react with KOH to give racemic mixture of product. Okay. So 3-bromo 3-bromo 3-methyl-hexane. Hexane is 6 carbon. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 and 6. And there is 3-bromo. Here 3-bromo and 3-methyl as well. Hexane react with aqueous KOH. Aqueous KOH give alpha beta elimination. So it will be like this way. Then it will be become this 1, 2, 3, 4, 5, 6, and it is OH. Okay. Uh, Identify the type of reaction. This is uh, nucleophilic substitution reaction because it is 3-methyl 3-bromo, so it is SN1 reaction. Okay, it is SN1 reaction. Now, draw the structure of the transition state. So, there is formation of carbocation. So, firstly, this Br remove here. So, the transition state is this. This is the transition state. The reaction, if bromine is replaced by fluorine, will the reaction proceed faster or slower? Okay, so if bromine replaced with fluorine, reaction reaction proceeds slowly. Why? Because the leaving group ability of Br minus is more, like much more than F minus. Okay, and F minus have like high bond dissociation energy. So these two factors replicate this answer. Okay. Then question number 74. Which compound in each of the following pairs will react faster by SN2 mechanism with OH and why? Okay. So in this SN2 is a single step process and the rate of reaction is 1 degree, 2 degree and 3 degree. So and for the alkyl halide, the iodination is more than bromination and then chlorination and then fluorination. Okay. So iodine will remove easily compared to bromination, and it is a 1 degree, it is a 3 degree, so 1 degree react first. So for the both, the second will be correct. Okay, the second will be faster towards SN2. Now 50 mg of Na2SO4 dissolved in 3 liter of water at 27 degrees Celsius. What would be the osmotic pressure of the solution? Osmotic pressure of the solution is like uh, osmotic pressure pi is equals to CRT. Okay, ICRT maybe. Pi is equals to ICRT. ICRT is like I into numbers of moles. Numbers of moles is given, not given. So given weight of solute upon molecular mass of solute. I'm moving volume here and then multiply by R and then multiply by T. Okay. So I is equals to pi is equals to I is Na2SO4, it convert into 2 Na2 1 plus SO4 2 minus, which is actually 3. So I will be 3 into given weight is 0. Given weight is 50 into 10 to the power minus 3 because it is in milligram. Na2SO4, so the weight of Na2SO4 is 120 and the volume is 3 liter. Okay, volume is 3 liter. R is temperature is 27, 273 is equals to 300, 300, and the value of R is 0.0821. Whenever we solve, we get pi is equals to 1.381. Question number 76. During a study trip, student visit a lake and took out water sample which was rich in potassium chloride salt. They performed the experiment and calculate the boiling point of the lake water is about 100.025 degrees Celsius. If 500 gram of water sample was used to calculation Kb is this, then 0.42 gram of KCl is 500 sample. What will be the observed molecular mass? Okay, so for the formula of observed molecular mass, m is equals to I multiply by Kb multiply by weight of solute multiply by 1000 upon weight of solvent multiply by delta Tb. Okay, so I is equals to 2 because it is KCl, Kb is given is 0.52, weight of the solute is 40, sorry, 0.42 gram. Okay, this is 0.42 gram and multiply by 1000. This is a formula based question. W is 500. Okay, because it is ml, so water have same like 1 gram per liter their density. Okay, so it will be 500 gram and then delta TB. The ideal boiling point of water is 100. 100 minus 100.05, it becomes 0.025. Okay, and whenever we solve this we get around 34.94 gram per mole. Okay, then the question number 77. A student X was doing an experiment by taking a 0.1 gram of acetic acid in 40 gram of benzene. He suddenly observed that freezing point of mixture is lowered by 0.4 degrees Celsius. Do you think the association of acetic acid has taken place? If yes, what will be the degree of dissociation? Okay, so yes, there is association because acetic acid form hydrogen bonding. So it will be like CH3, CO, and then OH. This OH is CH3, and then O, and then H, and then O. There is a hydrogen bonding. So association will take place. Okay. Now we calculate observed molecular mass, which is equals to I into Kf into W into 1000 from the formula, and W of solvent and delta Tf. Okay. Just put the value I is equals to 2 because it a formation of dimer. Then Kf is given as 5.12, 2 into 5.12 into weight of the 0.15 into 1000 divided by 40 into delta TF is delta TF is 0.40, and whenever we solve we get 96. Okay, so observe is 96. Now let's calculate. So I is equals to, alpha is equals to molecular mass observed, my molecular mass calculated divided by molecular mass observed multiply by n by n minus 1. Okay, so calculated molecular mass is CH3 COH 24 plus 4 32. Then it is 40 60. Okay, so 96 minus 60 and 96 minus 60 upon 96. Okay, 2 2 minus 1. So alpha is equals to 0.75. Okay.